Hello, everybody. Today we're going to be looking at exponential functions, and we're looking at the two types of exponential models that we have, which are both growth and decay models. And up to this point, we've mainly dealt with growth models, and today I'm going to show you what a model looks like that is a decay model. Okay, so if you take out the notes that hopefully the substitute gave you, what I want you to first do is up in the equation block of the first Freyer model, which is exponential growth, is label the parts of the exponential function as it's represented as an equation. So again, y is going to be your output, a is your starting point or the amount that you start with, b is your growth rate, and then x is going to be the input or the exponent. All right, so go ahead and pause now if you need to while you do that, and then you can resume once you have that written in. All right, so if we look over at the real world example, it says here you deposit $4,500 in an account that pays 5% interest compounded annually. Write an exponential function to model this scenario. Okay, so what we're going to do is we're going to start with y, because that's going to be the output. Okay, so y equals, the starting point is $4,500. Now, to find the base or the growth rate, we're going to have 1 plus 5% to the x power. Okay, so like we've already been doing, your answer is just going to be y equals 4,500 times 1.05 to the x power. So you would put in for x any amount of years that you're going to be compounding for, be it 2, 3, 4, 5, 10, or 12 years. You would just put that in for x. Okay? Now, when you look at the graph of an exponential growth function, notice that it is increasing from left to right. Okay? So just like a linear function, you read the graph from left to right, and you'll notice that from left to right, it starts off with smaller values and increases in values as the curve goes up. Okay, as far as the table is concerned, we're going to leave that for later, writing a rule for the table, because I will show that to you when I get back, how you can do that on Desmos as well as using your TI-84 graphing calculator. Okay, so we're going to leave the table blank for now. All right, so that's what an exponential growth model looks like. Now, the exponential decay model, the opposite of growth is going to be decay. So again, represented as an equation, y is still your output, a is still your starting point, b is your growth rate, and then x is your input or your exponent. All right, so what we see here is that a car was purchased for $18,000. The car depreciates by 20% each year. Write an exponential function to model this scenario. So since the car is depreciating, this is going to be a decay model. So it's going to be y equals my starting amount, which is 18,000. And this time I'm going to subtract the percentage instead of adding it, and then raise it to the exponent. So that's going to equal y equals 18,000 times 0.80 to the x power. All right, and that would be your how you would compute depreciation, which is decay or a decrease in value. All right, and then of course, if you look at the graph, you see this graph is decreasing from left to right. Okay, and like I said before, with the table on the other one, we're going to leave the table for later and do that on Desmos and your graphing calculator when I return. Okay, so for your assignment today, let me show you how we need to write these problems and what I'm expecting you to do, because it's just doing what we just did, growth and decay models. Okay, so if you read the first one, and this will pop out of Canvas, it says Quentin just read that his computer, which costs $2,500 new, loses 10% of its value every year. If this estimate is accurate, how much will the computer be worth in 15 years? Okay, so here's how we're going to write this. And this is exactly how I want to see you writing these for full credit. If you do not write it this way, you will not get credit. So y equals, my starting point is $2,500. Okay? It says he loses 10% of its value every year, so that is a decay model. And x represents the input of every year. So then it says, if the estimate is accurate, how much will the computer be worth in 15 years? So that's going to be y equals 2,500 times 0.90, because 1 minus 0.10 is 0.90, raised to the 15th power. Now this you can do on your calculator, okay, because you don't need to write out the big long decimal you're going to get when you do 90 hundredths to the 15th power, but then your answer is going to come out to 514.73. All right, so after 15 years, the computer will be worth $514.73. Okay, now if you look at number two says a fashion blog has 22,000 page views so far. In addition, that number continues to grow 25% every week. How many page views will the blog have in 2 weeks? So again, y equals, my starting amount is 22,000, okay? And it's growing at 25% per week, and the per week is represented by x because that represents change. So y equals 22,000. All right. And this time for x, I'm going to put in, we're looking at 2 weeks. So here my answer is going to be 34,375. Okay, so this is how every problem needs to be written out. I want to see you write an exponential model and then properly substitute the number in for the exponent. This way I know you know the process and understand how to use the process, okay? So if you look at also on your assignment here, number 3 and 5, I wrote those out for you because they're fraction exponents, which we really haven't gotten to. So those are already done for you. You just need to find the actual value. All right, so all 24 of these need to be done. And please take a photo and upload it to Canvas when you're finished so I can see your work. I will be on Google Meet if you have any questions. So have a great day, everybody, and thank you for listening.